Acha nikumake host. We are now.
Iko sawa? Iko sawa. Okay. Hope you can all hear me. You can see most people are joining right now. We can give them 2 minutes, 2 to 3 minutes to join so that you can start together. We're adding them 2 more minutes so that you can start at 9:10. So 2 more minutes to join. 2 more minutes. Two more minutes. Two more minutes. So I would like us to proceed from where we left. We have 1 minute more. Those who are joining, I'm giving them a next 1 minute. I want us to start exactly at 9:10. Exactly at 9:10. Exactly at 9:10. And see here you have a good number is joining. I want us to start at 9:10. 9:10. You're almost there. So you can activate your videos, eh? Activate your video so that you can interact properly. Activate your video, eh? Make sure you activate your video or you start your video. Everyone should start the video or activate your video. This is our last lesson of the term. So we need to see each other properly. So make sure that you activate your video, everyone. After connecting, you make sure that you activate your video so that I can see you. You are unmuted, but the video is on so that I can see properly. Last time we were dealing with the linear propagation of light, and we did finish. So today I want us to clear linear propagation of light. So that's what I want us to clear as we start our lesson. Remember last time we looked at a few areas, and I gave you an assignment. Remember, I told you to go to the internet and search the eclipse. I told you to look at eclipse of the moon, yeah, and eclipse of the sun. So we normally call it eclipse of the earth, okay, or eclipse of the sun, sorry. So the eclipse of the sun, we have eclipse of the sun. I told you to go and research on that. I know you're good in research. Did you manage? Yeah? Before we start, as the others join, I can invite somebody to quickly or briefly tell us what eclipse of the sun is all about. What is eclipse of the sun or solar eclipse? What do we call, or what is that thing that we call solar eclipse? Solar eclipse ndio nini? Activate your videos, please. Activate your video so that I can see you properly. Nitawasahau bana. Nataka niwasahau. You know, some people have grown old, others have grown very big. So I need to see you. Nione kama mnaongeza weight ama mmezeeka. So somebody to briefly from the assignment I gave to tell us what is the eclipse of the sun or solar eclipse. What is it all about? Somebody? Mtu ainue mkono aniambie. Wasomi. Make sure that you activate your video. You might be kicked out of the lesson anytime. So unahitajika tuonane, tujuane. I need to see who I'm dealing with. Okay. Anybody? Hakuna mtu alifanya research. Just watching, you tell me what is the sun is between or the moon is between this and this. So what falls, which shade, kind of a shade that falls, evil. Just that, a brief explanation of what you found out or what you researched on. Anybody? Sioni mtu anainua mkono. Anyone? You don't know what is the eclipse of the sun? Good. You can unmute this. Mtu amejiita jina hapo, start to mention, but you can tell us what is happening. Unmute. What is the eclipse of the sun, or what is solar eclipse? What is it all about?
It is the blocking of the sun rays from reaching the Earth's surface when the moon passes between the Earth and the sun.
Very good. When the moon passes between the what and what? The Earth and the sun. So it blocks the sun rays from reaching the Earth. Right?
Yes.
Therefore, this is what we form. We have the Earth. We have the sun there. We have so what we have there, we have the sun there. Then you have the Earth and the moon here. That's the moon, eh? So we have the first rays, sorry, the rays of this, they move like this. I need to move this up. I need to move it up a little bit like this, sorry. Kidogo tu. I need to move it like this, eh? Up kidogo, like that. That now I can draw my rays. And remember, my rays must be having arrows. Then we have another set of rays here. Then this should fall on the earth surface like that. So probably like that. So the linear is supposed to be a bit smaller. So drawing this is a bit tricky in sometimes because you must be very careful on how you are drawing your knee. You must be very careful on how you are drawing your circles. Otherwise, they might not form what you want. This is the earth. It must be, let us make it that small. That is the moon. And this is the earth. So I want to draw them again quickly. This is eclipse of the sun or solar eclipse. That's the first ray, like this. Remember, this will be behaving like a point source, like an extended source of light. Then we draw like this. Good. Sasa imeweza. This is how it is drawn, if you are taught to draw. So, okay. Probably, maybe the earth could be a bit lower, but there are two types of shadows that will form here. There are two types of shadows that we are going to form. There is one shadow that is very dark, called what? It's called what? Umbra. So this umbra here. That is umbra. That will fall on the surface of the earth. And then we have you can see our umbra. Then we have, let's change, another shadow that is a bit faint. It is called what? Penumbra. So we'll be having two regions or two shadows. So this is umbra. This is the moon. Okay, we have the moon here. This is the earth. This is the moon. This is the sun. So you can see the way these rays are behaving. Okay. must put arrows, and although I'm putting them naziweka kienyeji kidogo. Good. So those are the rays that you normally have. Okay. A question? Somebody with a question? So you're okay. So that's how you're supposed to form. That is what we call eclipse of the earth. I might need a solar eclipse. So we have the two types of shades. Hapa kuna umbra, hapa. Umbra. Hii inaitwa umbra. Then this region has penumbra. As penumbra. This upper and the lower region. I think you know those types of shadows that we have already discussed. We have really discussed those types of shadows. Another one, the other type of eclipse is we have that solar eclipse. Then we have lunar eclipse, eclipse of the moon. But sometimes, before we go to the lunar eclipse, sometimes the umbra of the moon is not long enough. The umbra of the moon is not long enough to reach the. So in case, I think I can write that here. In case the umbra of the moon is not long enough to reach the Earth's surface, I think I can first of all write this is called. We normally call it eclipse of the moon, or the solar eclipse. Or eclipse of the moon. Okay, we call it solar eclipse or eclipse of the moon. So I want you to know something. NB. Sometimes during that eclipse that we're talking about, that the eclipse of the moon or the solar eclipse. I've said solar eclipse is also called, no, this eclipse of the sun, sorry. Should clear this. Sorry for that. Should be solar eclipse, or we call it solar eclipse or eclipse of the sun. Solar eclipse. And in case you have any kind of typing error or something, you can raise up your hand and we correct as you proceed. We're supposed to be very interactive, so so in case you see any typing error or anything, we write, in case we write moon instead of sun, we can raise up we're supposed to interact. So don't fear, you can raise up your hand anytime when we correct anything. So solar eclipse or eclipse of the sun. Solar eclipse or eclipse of the sun. That's how we call it. Call it solar eclipse or eclipse of the. We call it solar eclipse or eclipse of the sun. So there's something I was saying that sometimes, just a minute. Kidogo tu. So I was saying, eclipse of the sun or solar eclipse. So there are some cases, a special case in solar eclipse. So that's what I was trying to discuss. So Nicole nimesema NB. There is a special types of an eclipse called annular eclipse. That's what I want us to discuss. How does it come about? So I was saying that NP sometimes the umbra Sometimes the umbra of the moon is not long enough to reach the Earth's surface. The umbra of the moon is not long enough to reach the Earth's surface. The Earth's surface. Therefore, what happens? Reach the Earth's surface because of the distance between the moon and the Earth. So therefore, when the moon is farther away from the Earth, the disk is slightly smaller than the Earth disk. So the solar eclipse occurs, the moon is not large enough to cover the sun totally. So a bright light of the sunlight can be seen around the edge of the dark moon. So what happens? So therefore, we can write that. Can start a new menu. So therefore, so we can say that in this case, what happens in such a case, when the moon is not long enough to reach the Earth's surface, the distance between the moon, because sometimes the distance varies between the moon and the sun. So when the moon is further away from the Earth, so you can see that when the moon is further away from the sun, the moon is further away from the sun, when the moon is further away from the sorry, it should be from the, when the moon is further away, sorry for that mistake, when the moon is further from the Earth, when the moon is further away from the Earth, the disk is slightly smaller than the sun. The disk is slightly the disk is slightly smaller than the sun's disk. So what do we experience? Well, because the disk of the moon is slightly smaller than the sun's disk. So this is what you experience. We experience this. We experience this. I want to draw here what we experience. First of all, this is a kind of what. So you're going to see during the annular eclipse. This is what you always see. You expect to see something that looks like this. Okay, angalia utaona kitu kama hii. Utaona kitu kama hii. This is what you will see. You will see a ring, a moon with a ring like this. So you're going to see when the solar eclipse occurs, the moon is not large enough to cover the sun totally. So a bright light ring like this. I want to have a dark one. Yes, exactly like this. So we'll be having something that looks like this. So utakuwa unaona moon, but the moon will be covered by a ring. So this is what we'll be seeing, because now the moon is not able to cover. It's true, the moon is between the sun and the Earth, but it's not able to cover the sun totally. Okay. Therefore, because some light will be passing through, because the moon is smaller than the earth. Of course, it's smaller than the sun and also smaller than the earth. So we expect the moon to be, if the moon is smaller than the sun, so there are some rays of light that will be passing through. So what you'll be seeing a moon that is covered by a what? By a ring. So I can write something there and say that that's a special case of a solar eclipse. So what we'll be seeing is this. So a bright ring of sunlight of sun, a bright ring of sunlight, a bright ring of sunlight can be seen around the edge of the dark disk. Can be seen around the edge of the dark disk of the moon. So what causes all this? When the moon is between sun and the earth, but the distance between the sun is very, very far away from it's a bit far from the earth's surface. Therefore, the umbra cannot fall on the earth's surface. So it will be closer to the sun, but smaller than the sun. Therefore, it cannot be able to cover the sun completely. Therefore, because of the rays of the sun that will be passing over the moon, you'll be seeing a moon that is covered by a very bright what? Will be covered by a bright ring. So a bright ring will be covering the moon like that. So that's a special case of solar eclipse. Quickly, I can clear this, right? So you can clear this. So I clear that so that we can quickly discuss the eclipse of the lunar eclipse, or my eclipse of the moon. Do I clear that? Niondoe hiyo eh?
Yes.
Okay. Yes. Let me clear that so that we can quickly. I know our time is so much limited, so lazima tuchangamke tuende haraka haraka. Being our last lesson, we also need to be very organized, and we make sure that we cover something substantial, something good. Kila mtu aelewe. So this I want us to. I want us to share the screen here and write about lunar eclipse. So andika lunar eclipse quickly. Lunar eclipse. I want to clear that. And I want to write about lunar eclipse. Lunar eclipse. Or eclipse of what? Of the moon. And we need a lunar eclipse or eclipse of the moon. There we go. I want us to draw this one now. The moon, the earth is between the sun and the moon. Of course, the earth is bigger than the moon. Is there any objection there? Between the earth and the moon, what is bigger? Of course, the earth is bigger. Where we are the earth to the kubwa kuliko moon. Our moon is kubwa kuliko earth. So probably, I know you. Some people have visited the moon. Of course, not you, and they have seen. I know in future, if you come visit in future, you are going to visit the moon. I want to have the sun there. And then I have the Earth. I can push it a little bit. Then, of course, the moon is there, very small. That is our moon. So we'll be having, rays that will move like this. That's how they behave. So what the moon experiences total darkness because there are no rays that are fast, that are, the moon moves like this. The moon is supposed to move out there. The moon is supposed to move like this. The moon moves, is it clockwise or anti-clockwise direction? It moves
Clockwise.
Clockwise. Na vile nimechora vibaya. Nilijaribu kuchora mzuri. The moon is supposed to move like this. So inamaanisha kuna wakati uko nyuma ya Earth. There is a specific time that the sun, let me write. I can write the sun there. Huyu naye anaitwa nani? Good. Na huyu naye anaitwa nani? Andika tu kwa sababu ni kadogo wakati atasha hiyo nini. Sasa there is a time that the moon will find itself behind the what? And it is smaller. So there will be total darkness because there are no rays that will fall on the surface of the moon. So what we experience behind the sun, the Earth here, will be total darkness. Right?
Yes.
So we are going to experience total darkness. So I'm trying to shade this equal dark. So we experience this. So these are so how do you make this total darkness?
You shade.
I want us to shade it dark, completely dark. Hata moon haitaonekana. Okay, wewe jua tu itakuwa total darkness. Tu kama hiyo. So moon will be there but totally dark. So they experience blackout. Kama mliona eclipse, sisi kama mnaonanga eclipse. Last time, did you see the eclipse last time?
Yes.
Mliona? Ilikuwa eclipse gani ilikuja latest?
Tuliona.
Lunar eclipse.
Yeah?
Lunar eclipse.
Ilikuwa lunar. So ukienda kuona pale. So because of time, I'll not be able to show the whole of that. But to that side of, because there are no rays that are falling on the surface of the moon, or there are no rays that are falling on, behind the Earth. That would be the experience that would be total darkness. So, but on the Earth's surface, there is no given time that will have total darkness on the Earth because the Earth is bigger than the moon. So they are during the eclipse of the sun or the solar eclipse, the moon between the Earth and the sun, we have two types of shadows that are formed. One is umbra, then penumbra. The section where we have the umbra, there is total darkness, but the other sections have partial darkness, right? Yeah,
Yes.
so that's the case. So pinhole camera, did we look at the pinhole camera?
Yes.
Yeah, we looked at it. I can just draw a question and see how far you got. Just a question and see whether you can be able to answer comfortably from the pinhole camera. So I want us to write this question, a quick one, just to test your just check whether you are there or understood what was happening. So andika hii chap. I want to clear this. I want to clear the whole of this. So andaka uandike hii. This is from this is what we have covered or we covered last time. So I just want to give a quick test of one question. Nione kama mko sawa. Unajaribu andika an object of height. An object of height 5 meters is placed 10 meters. Is placed 10 meters away from a pinhole camera. From a pinhole camera. Calculate the size of the image if its magnification its magnification is 0.01. 0.01. Then if the length of the pinhole camera the length of the pinhole camera, those two. Just a minute to do that. Dakika ngapi? Dakika mbili. 2 minutes. You clear that. Sawa. Cleared? Ukimaliza unainua mkono. I'll see. You're done? Yeah, that's a very simple question. Ako ni karahisi. So easy. Can see some, but how many people? Okay, let me see. Ndegwa, your hand is up. You have, you can answer for us. Amani mwenda, tuchukue mwenda. Ndegwa, umepata? Kuna mtu? Okay, I can select somebody else because naona huyu amezubaa kidogo. Who else? I think by now almost everyone should be done. Everyone is supposed to have finished. So I think we can mark for ourselves. I can quickly give the answer so that you can check whether you have gotten it or not. So the first thing you're supposed to understand is, let me see. Okay, so I can quickly do it because of time. If I allow you to do it, it might take a lot of time, and there's something else I want us to cover before the end of our lesson. Ama nani yeye anajibu? Mtajibu ama nijibu? Let me answer for you so that we can save much of our time. So quickly what you do, I'm starting with question 1, the first question here. So we are told to get the size of the what? The size of the image, and the magnification is given. So tunasema magnification, you need to say it. Magnification is equal to what? Height of the image over height of the object. Height of the height over the height of the object. Height of the image over the height of the object.
Rada.
In this particular case, so what is the magnification is already given as 0.01 is equal to height of the image over height of the object. Is the height of the object given? Yeah, you're given it as 5 meters. So height of the image is equal to 0.01 times what? Times 5 to get 0.0. 0.05 meters. So, and quickly, the other one is part B. You are told to get the length of the pinhole camera. The length of the pinhole camera is actually the what? Is the image distance. That is supposed to be the image distance. I want to do it here using a different color so that you can. So magnification again is equal to image distance over object distance, or you can call it V over U. V over U. So therefore, we're going to say that 0.01 is equal to 0.01 is equal to V over U. U is given already as 10. So you're given V as 10 meters. Yeah, it's supposed to be given. It's given as 10 meters. So V will be equal to it will be equal to 0.01 times 10 to get 0.1 meters or 10 centimeters. So it will be 10 centimeters or 0.1 centimeters. So how about hizo answers being correct? How many people have gotten all those answers correct? Huh? Okay. Yeah. Now, quickly, we go to then I can see so many people have raised up their hands. So it means we are moving on well. So quickly, I want us to look at reflection, laws of reflection. Like, thank you. Nimeona mmejaribu. I've seen you have done a good job. So let's write this. Let's write laws of reflection. What are the laws of reflection of light? Which laws do you know? I want us to write them here. Let me clear this. I can clear my board. So laws of reflection. Reflection. Laws of reflection. One. Hii hata same kitu. Hii nataka mtu mmoja aniambie. Mtu ainua mkono. One. Yuko mtu anajua the first law of reflection? Really?
Angle of incidence and the angle of reflection are equal.
Very good. Angle of incidence is equal to the angle of reflection. That's very good. Angle of incidence is equal to the angle of reflection. Number two.
The incident, the normal, the incident, the normal, and the reflected ray.
The incidence. Ngoja tuende pamoja. The incidence ray.
The normal
Incidence. The incidence ray.
The normal.
The normal.
And the reflected.
And the
reflected.
And the reflected ray.
Look at the same point. It in one plane at the point of incidence.
For the normal, the incidence ray and the normal and the reflected ray, they all fall in the same plane.
The point of incidence.
Yeah?
Yes, they fall at the same plane in the point
the normal,
of incidence.
So I've said we are saying that the angle of the normal, and they all fall on the same plane. They all fall on the same plane. Fall on the same plane. How? They operate or they fall on the same plane. So the angle of incidence is and the angle of, are equal. The normal is the line drawn perpendicularly from the point where the reflected ray and that bounces on the reflecting surface. The angle of reflection is the angle between the reflected and the. So what is those angles? Let me just draw them here. What are these things we are calling incidence ray? So we can quickly draw them here. If I draw a plane here, I want to draw a plane here. Sorry, plane. That's my plane. So I have the incidence ray. Incidence ray. So I want us to draw it like this. Takuja igonga wapi? Hapo. See there?
Yes.
Let me undo. Supposed to be like this.
Sakoro, what are the laws of reflection?
Okay, nikikuwa mute usiongee tafadhali. When I am unmute you, I expect you to be very disciplined. Eh?
Yes.
Don't unmuted. Don't take advantage. I've unmuted you because I'm suspecting that you are very disciplined.
James, how was your day? I didn't even summer.
Misbehave. So kwa heri, kila mtu ana
Hivi hivyo pia kama kitu kitafanyika leo usiku.
So then we have another ray that is here. So if I unmute you and we see I'm reluctant on muting you, I'm thinking that you can control yourself. Kini nikiona huwezi control si na kuzima tu. Sababu umeprove you cannot control yourself. So wala kuna watu huwa na unmute na naona wako sawa. Some people are very good. Mtu anakuwa na discipline ya hali ya juu. Lakini mwingine ukimwanmute hata ataanza kuongea nini? Now, I was drawing for you this so that you can identify. So this one is this is incident ray. And this one, this is a normal. This is a reflected. Reflected ray. Reflected ray. These angles are supposed to be the same. So this angle, that angle, this angle and this angle are supposed to be the same. So angle of incidence is that, angle of reflection is that. So I is equal to R. So I is equal to R. That's how they're supposed to be. Angle of incidence is equal to the angle of reflection. Angle of incidence is equal to the angle of incidence. Why am I drawing all this? Because there's something I want us to discuss here. I want us to discuss something very sensitive here. So, quickly, just want to do something here. That's the plane. That's our plane there. You can see, so these are plane. So I want us to rotate a mirror and see. There's an experiment that's normally done here for us to prove those laws of reflection by drawing some pins here. So you check from the other side, you can see the reflected ray. So you try to place those along that line that you can see inside, and the normal is there given. You draw your normal very well. Then you try to measure those angles. The angles that you form there, you'll have the first angle as the angle of incidence, and the second angle as the second angle as the angle of reflection. Therefore, we are supposed to note that the two angles are supposed to be equal, as long as you are using a plane mirror, a plane mirror. So angle of incidence is equal to angle of reflection. And also you're going to look at the other types of mirrors and you'll see how they behave. But for now, at your level, what you need is to know about a plane mirror, the one you normally use at home. You start from what you know, from what you don't know. Sasa, I want us to turn a mirror. If ukishika, I'll be satisfied. I want us to rotate a mirror, to rotating a mirror. Can I clear this? I can clear this, eh? I hope you have finished this. So rotating a mirror at an angle, rotation of through an angle. So this is a very sensitive area where some people need to really concentrate to honor how we rotate a mirror. So we are going to do it. Be very keen. So because I'm doing it once only, and I'm sure everyone will understand it. So right, rotating a mirror. Rotating a mirror through an angle. Rotating a mirror through an angle. I'm sure you have seen this question in the exam. Some people got it, others didn't. So the first thing to have, we are supposed to have a mirror here. I want us to have a mirror. Let's see whether these colors will help us. Let's see. I just want to test whether the colors will assist us get the. So if I'm having a mirror here, if I'm having a mirror, I should have a mirror here, which is my original plane here. And probably I can shade it a little bit to make it a plane like that. That's my mirror here. Of course, okay. That's my mirror. So quickly, I draw my incident ray. I draw my normal. And then I draw my reflected ray. Those two angles are supposed to be the same. So I write, this could be 30 degrees. I want a straight here. Or it can even be Maybe it can be 50 degrees, 40, and this 40 degrees. 40 degrees. Because of what we know that angle of incidence is equal to the angle of reflection. Remember, the normal is supposed to be perpendicular to the what? It's supposed to be perpendicular to the supposed to be perpendicular to the plane. So remember what we said, that every time you're having should make sure that array must have an arrow like that. Array is supposed to be identified by what? An arrow. So you must include an arrow there to show that although the angles don't look the same, we are supposed to know that they're the same in. They're the same. They're supposed to be the same. I want to rotate this mirror by an angle of 10 degrees or 15 degrees. So rotate an angle, rotate by rotate. So 15 degrees. 15 degrees rotation. When you're rotating, you must identify, or you must indicate whether it is clockwise or anti-clockwise. Okay, hello. So you're supposed to understand that the incident ray is constant, it doesn't move. So in incident ray, it is constant, it doesn't move. So the rest are free to move, but the incident ray will never move, right? That's something you need to understand. There's some things I need to move here. There's a lot of confusion happening. So quickly, the incident ray remains constant like that, but here I've moved an angle of 15 degrees. I've moved an angle of 15 degrees. 15 degrees like that. Therefore, the incident ray so if I move here, then remember something else. I want to write those key points here. Those are the ones that will help you understand. Incident ray does not move. Doesn't move. Then something else. The mirror moves together with the normal. Something else that you need to note here. The mirror moves together with normal. The mirror moves together with the normal. Those are the key points that will help you understand this. So I'm moving my mirror. Therefore, if I'm moving my mirror, I should move my mirror together with the normal. So my normal will move. My normal will move. So this remember, note that normal doesn't have an arrow. So this is normal 1. I can call this normal 1. That's normal 1. And this is normal 2. This is normal 2. The second normal. Therefore, this normal will move how many degrees? If the mirror is moving at 100, at 15, so the normal will also move at the same 15 degrees. So the new angle of incidence will become 55 degrees. Remember the old angle of incidence was 40. Now our new angle of incidence becomes 55. We follow the laws of reflection, which says that angle of incidence must be equal to the angle of rotation. No, the angle of incidence must be equal to the angle of reflection, sorry, the angle of reflection. So I want to draw this quickly, like that. So I should make sure that this angle of reflection becomes 55 again. It should be 55. 55. I hope you are following. I hope everyone is getting it. This is your chance to understand this concept. Very important. So there's something I want you to understand now. What is the difference between the new reflected ray and the old reflected ray? Because that's the question now. Basically, that's what the question is always about. You are normally asked, let me just write this reflection R1, and this R2. This is the first ray of reflection. This is the second ray of reflection. Let me just draw the arrows so that you can. This is a mirror. So the mirror is there. The mirror doesn't have an arrow. The mirror cannot have an arrow. So this is what is happening. So what is the angle between? All right, I'm going to write the question here. What's the angle? Somebody tell me, what is the angle between the, what is the angle? Sorry, I'm trying to do this. The question is, what is the angle? Is, I can see Moses, Carissa raising up the hand. Good, I'll let you answer. Let me just write the question, then you will answer for us. What is the angle between the angle, the new, the old, or the old and the new reflected ray. What's the angle between the new and the old reflected ray? Who was raising up the hand? Two people to answer. Let me see. Who are those people who want to answer? The angle between, they can unmute themselves. Okay. Okay, you can unmute. Are you Mulumba? Kuna Mulumba, kuna, there's so many people who are willing to answer that question. Okay. I can see Moses also. So whoever answers, it's okay.
Yes.
What is the angle between the new and the old reflected ray?
It should be 30 degrees.
Why that?
Because we noted that when the mirror is rotated, in that angle, it doubles the number of degrees that it has been rotated.
It doubles, right? Very good. It doubles. The nini is supposed to be doubled. But now, how does it come about? I want to explain how it comes about. That's very good. Thank you. You didn't have the concept, but yes. How you're supposed to come up with that? How does that double come in? Hiyo double inakuja namna gani? Inakuja namna gani hiyo double? Or you can try to explain.
Maybe it is because if you rotate it, the incident ray remains at the same point, but the reflected ray keeps on moving. So it means the first 15 degrees from the initial place, and when it is rotated, if the incident could be rotating, then I think it could be the same.
Raise up your voice kidogo tukusikie vizuri.
Yes, I think it doubles because the incident, when it is rotated, it remains at the same place and the reflected keeps moving. If, for example, we assume that the incident ray could be moving, it should be 50 degrees. But now it is at the same place and the mirror keeps rotating. So it means that it is the same place, and when it is rotated, it means that the reflected ray and the normal check another distance. It means that the reflected ray will go at a higher distance.
So ungekuwa na uwezo ungekupigia makofi. Tungekupigia makofi. Because you have really tried, So this is what is happening, Unaona hapa? You can see this. Unaona hapa kuna hii angle. This angle between, that's very good. I was just want to give you a backup on the same. Look at the original, the ones in blue. Is in green, the normal is in green, and the reflected ray is in green. So there is a 40. Hapo kutoka kwa 40. Remember, what is constant is the incident ray. It doesn't move at all. Sasa angle itakuwa 40 na 40 to make it 80. So the angle between the incident ray and the reflected ray is 40 plus 40 to get 80. Look at the old one, the new one now after the case has changed. The angle of incidence has changed because you have moved the mirror. You have moved the mirror and the angle has changed to 55. So itakuwa 55 incident and another 55 here reflection. To make it, what is 55 plus 55? 110. So if you want to get the angle between the old and the new incident ray, you subtract 110 minus 80 to get 30. So, understood?
Yes.
Kako sawa?
Yes.
The same case happens when you're moving in an anti-clockwise direction. If you are moving in an anti-clockwise direction. So the same case happens. The only thing that changes is the direction, nothing else. Direction peke yake. So can I give a question on that? I have a question there that I can give you. I have a question here. So I'll do it in form of an exercise later. So because I can see I have only 6 minutes to go, only 6. Do I clear this? I have 6 minutes only to go. So what if you are given this? Nataka mjaribu hii dakika kidogo tu, tuko na dakika kidogo. I clear this, eh? I know you're now done. I was giving you some few seconds to finish. I clear? Can I clear? Yeah, let me clear that.
Yes, can clear. Mulumba.
Good. So I want to give you this. You're given this kind of a question, and we always follow the rules that says that the angle of incidence is equal to the angle of reflection. So I want to draw this, and this is the mirror. This is a mirror. So then that's a mirror. I want us to draw 2 lines. Then there's a wall here. That's a wall. At 20 degrees. There is a mirror. That mirror is inclined at 20 degrees. That mirror is inclined at 20 degrees. So there's a ray of light that is here. that ray hits the mirror like that. You're told a suspended plane mirror makes an angle of 20 with the wall. Light from the window strikes the mirror horizontally. Horizontally means that this angle is 90. Some people, kuna mtu ameinua mkono. Somebody is raising up the hand. Nani anainua mkono? Okay, I can be finishing. Okay, somebody. Before we get what he's saying, so light from the window strikes the mirror horizontally. Find the angle of incidence. Find the angle of incidence. Find the angle of incidence. So in 90, hii inakuja na 90 hivi. So inakuja na 90 hapa hivi. So inaingia hivyo na 90. So tell me, what is the angle of incidence? So before, because of time, I could have given you a chance to answer, but now I want to explain to you because I don't have enough time. So what we do, this is 90. So obviously umejua ni 90, kwa hivyo hata hii ni 90. Hiyo ni 90. So hii imebaki ni ngapi? Ile imebaki hapo ni ngapi? 70. Sindio? Because 90 is the angles of a triangle are supposed to add up to 180. Alafu here we must draw a normal. We must draw a normal and we call it n. I want to call it n normal. So if that is my normal, what will be my angle of incidence? So in this case, my angle of incidence will be 20. Because we know from 70, we must add 20 to go to the normal. Normal is supposed to be. So having identified our angle of incidence, we also need to, we can easily get, I can write this, like that. So we can easily get the angle of reflection. Using the laws of reflection, we are supposed to know that angle of incidence is equal to the angle of reflection. So quickly, I can easily draw this. Can draw another line here, which will be my angle of another 20. So it's supposed to behave like this, like that. So that will be another 20. Will be another 20 degrees. So we follow the rules that we have just learned today. Austin. Austin, umeinua mkono. Kuna mtu ameinua mkono hapo? Somebody has raised up his hand. So that's Nini. That is how you're supposed to handle those questions. You're supposed to make sure that you handle them carefully, that you ensure that you're following the rules clearly, that the angle of incidence is always supposed to be equal to the angle of reflection. If you follow that, you'll never go wrong. You'll never go wrong. So as I end, I can mention something about angles, mirrors at an angle. If you put mirrors at an angle, there is a method that we use. I want to mention that before I close, before we end our lesson. Mirrors at an angle, just mention that. So we normally say, when we are dealing with mirrors at an angle, which formula do we normally use? So inakuanga, it's normally 360. So 360 over theta minus 1. For example, if you put angles at a 90 angle of 90 degrees, the number of images will be 360 over 90 minus 1. So it will be 360 is 4 minus 1 to get 3. If you do it practical, you're also going to get that. So assignment will be there. You can go to rectilinear propagation of light in Form 1 topic from KMF. You answer those questions as you wait for holiday assignment. So you'll be having some questions to be doing over the holiday assignment. Otherwise, the lesson was good. No one has misbehaved. Things have been very good. I've also enjoyed the lesson, actually. It was a nice lesson. So I expect you to continue the same way. Keep safe. Holiday imekuja, ndio hii, August holiday. Make sure that you're safe. We want you back, all of you back safe. Kila mtu akuwe safe. Na tukutane, we can meet, we'll meet. Takutana Mungu akipenda. Because somebody is saying that he hasn't understood. Kuna mtu amesema hivyo. So you can reach out. You can reach me out on this number if you want any assistance. You can reach out through this number. You can take the number is 0724 779 663. So ukitaka kusaidizi, if you want anything to do with the physics, mathematics, unataka kusaidiwa, you can reach out. You can use that number to reach me. I want to repeat, the number is 0724 779 663. Ifikie hapo. We are also having another program, an online program. If you want to know about that program you're having, you can try to reach me through that number. You have a very nice program of August, a certain interactive online program. Tuko nayo ya August. So if you want to know more about that program, text me through WhatsApp, through that number. Nitakuelezea vizuri. It is a very enjoyable thing that we want to go to do over the holiday. So a very productive thing, interactive. We interact with other people from other areas and see how other people normally do their things. So if you want to know more about that program, call me or text me through that number, 0724 779 663. You carry out. Najua mko disciplined, hamwezi misuse. Mtanipigia tuongee ama you can text me through WhatsApp. And when you text me, you tell me your name first, na class. And I'm so and so from this class. It's a very nice thing. So, waendelea kusoma, perfect what you have done. Just perfect, kwa sababu una kitu kingine ya kufanya. Right now, the only thing you can do, the safest thing you can do to yourself is to perfect the far you have gone. Perfect. Kama ni form 2 work, you can clear the form 2 work. Unaifanya tu perfect, because this is a challenge that is affecting everyone, not me, not you alone. This is a challenge that is affecting almost, not actually, it's affecting the whole world. So usianze kusema sisi tuko na shida, tuko nyumbani. No, it's just a challenge that is across the whole world. So you're not disadvantaged in any way. So the only thing you can do to yourself is to perfect. So that when you come back to school, hautakuja kustruggle tena. Hatukufikiria ati like linear propagation of light nini. You are struggling to understand that what is the lunar eclipse, what is solar eclipse. Those are things that you are supposed to perfect. So that they will lay a very strong foundation. Hata ukienda campus, hautakuwa na struggle. You will not be struggling to do your things because you understand the concepts very well. So make sure that you take advantage of this time and utafanya vizuri. So that's the end of our lesson. Tutakutana baadaye. Have yourself a nice holiday. Have yourself a nice holiday. Okay? Anything? Any question? Everyone is unmuted. You can mention something if you are pressurized to do that. So nikiona mtu, Uko sawa, tunaweza malizia meeting hapo. Naona kila mtu ako sawa, but ule mtu nimeona ametext hapo hajaelewa something, you can reach me out through that number. Ndio nitakupatia namba. So feel free to interact anytime. Hata ukiona umenitext nimechelewa kujibu bado nitajibu. You can remind me if you find that I'm a bit late in answering some messages. I mean, we have so many. So we can end our meeting at that point. So have a good holiday.